Hello and welcome to part 4 of this course on temperature measurement using sensors. In this session, we will understand about measuring temperature using pyrometry. So far, I have covered the first three types, and here we are talking about the radiative type pyrometry. Pyrometers are used to measure heat emitted by an object. Radiation is emitted by every object when it is hot. This radiation is referred to as infrared because majority of the radiation falls within the region above the visible red light in the electromagnetic spectrum. Radiated energy is useful in determining temperature of the body being measured. This heat energy is received by a detecting device and transformed into electric signals. Some other properties of pyrometry are: it is a non-contact sensor. The amount of energy a surface emits is a function of temperature and emissivity. Pyrometry offers accurate, economic, and fast response. Pyrometers offer other advantages as well. They can measure temperatures of moving objects and inaccessible objects and can also be used with highly aggressive materials such as acids in chemical processes without any damage to the sensor. Some of the application areas of pyrometers are in metallurgy, smelter industry, hot air balloons and steam boilers, measuring temperatures of liquid metals or highly heated materials, and measuring furnace temperatures. We have two types of pyrometers. First one is total radiation pyrometer. The next one is infrared pyrometer. So let's understand the first one, total radiation pyrometer. The total radiation pyrometer receives all the radiation from a hot body, which is received by a sensitive temperature transducer such as thermocouple. Total radiation includes both visible and infrared radiation. In this type of pyrometer, lens is used to focus the radiation on a radiant energy sensing transducers. In this arrangement, both absorption and reflection are absent. So, the entire radiation is captured. Total radiation pyrometers are mostly used in the temperature range of 1200 to 3500 degrees centigrades. The second one is infrared pyrometers. Infrared pyrometers are partial or selective radiation pyrometers. Above temperatures of 400 degrees centigrades, a surface starts to radiate visible light energy, and simultaneously there is a proportional increase in the infrared energy. Basically, photovoltaic cells are used in radiation pyrometers as it responds to wavelength in infrared region. All infrared systems depend on the transmission of infrared radiant energy being emitted by a heated body to a detector in the measurement system. The sensor head is focused on the object whose temperature is being measured or controlled. Now let us make a comparison of commonly used temperature sensors. If we talk about thermocouple, it has advantages of simple and easy to use. Of course, it has fast response time with wide temperature range. But the disadvantages are it needs frequent calibration and it's susceptible to noise and corrosion, so it is highly sensitive. If we talk about RTD, it has good stability with high accuracy and it is resistant to contamination. But The cost is high. It is sensitive to shocks and vibrations, and it is fragile. Talking about infrared pyrometer, it provides non-contact measurement. Measurement of device in remote location is possible. It has fast response time with high accuracy if emissivity of device is known. But the disadvantages are the measurement is not possible if device is covered with glass box, and the initial cost of pyrometer is quite high. So topics in my next part includes the methods to measure temperature, non-contact method of temperature measurement using thermography. Till then, if you have any doubts, you can mail me at the given mail ID. Thank you and happy learning.